Hi, it's time for another math easy solution. To discuss further into polar coordinates, and now look at part 2 of example 6, which looks at question B of my last video. And basically this question is going to be involving converting a polar circle to Cartesian coordinates. And yeah, basically to recap, question A of this example I did in my last video, so check that out, which involves sketching the curve with polar equation r equals 2 cosine theta. And then what I did, I just graphed a bunch of points and then got a circle, I guess a bunch of, yeah, it looks very detailed and tedious, but so make sure to watch the video and see how I did that all by hand. And now what we'll do is look at question B right here. Find a Cartesian equation for this curve, this one, r equals to 2 cosine theta. So let's take a look at that. Yeah, so what we have is r is equal to 2 cosine theta, and what we could do is draw the polar coordinate system on top of the Cartesian coordinate system. So what we'll do is just draw xy like this, yeah, where that's x and this is y, and let's just draw a point here. So this point, if let's say the distance here is going to be r, and this angle across from this x-axis or the polar axis is going to be theta, then what we have is at this point in polar coordinates this is r theta, but this is the same thing as well if we draw a right angle triangle, just a vertical line down where the height is y and the length is x, like this on this x and y axis. So this point is the same thing as writing, well, x and y. Yeah, so now the next step in converting this equation into Cartesian, well, we could just use the basic trigonometric functions here. And we know that the trig ratios for cosine, that's just cosine theta, is going to be adjacent over hypotenuse, that's just x over r. And likewise for sine, sine is going to be, well, sine theta equals to opposite over hypotenuse, y over r, like that. So yeah, this is what we have here, but notice that we have this cosine theta, and we know cosine theta is equal to this. So what that means is we can throw this x over r inside this cosine theta. So what we end up getting is a r equals 2 cosine theta, which equals to, well, 2 times x over r. And then what we can do is move the r to the left side, and then what we'll end up having is an r squared equals to 2x. Yeah, so that's what we have. But we also know that by the Pythagorean theorem, we have x squared plus y squared equals to r squared. So recall, all right, Pythagorean theorem, like that. So what we have is r squared just equal to x squared plus y squared. So, but then we can just throw this inside there. Yeah, so we can highlight this and throw this inside. So then what we end up having finally is, well, x squared plus y squared, that's equal to r squared, equals to, well, just 2x, like that. So put that in there and then throw this back down. So we have this equation. Yeah, so now next step I'm going to do is I'm going to move this into here, then we'll complete this square. So what we end up having is x squared minus 2x plus y squared equals to, well, 0. So now this part here, what we could do is look at this separately. So I'll highlight this, and so I'll highlight that after. So we're going to look at this one. So recall or note, I'll just write note instead. We're going to complete this square, but I'll just do this manually. So basically, if we have, let's say, x minus a squared, this is just the same thing as writing, well, x minus a times x minus a. The reason here what I'm going to try to do is get rid of this 2x, put this all under one square value. So when we multiply this out, well, this times it by this is just x squared, and then added to, when you just expand this, x times negative a, that's going to be negative ax, and then same thing here, negative a times x, that's going to be negative ax. That combines to negative 2ax when you just combine the two, and then negative a times negative a is just plus a squared. So yeah, we have something that looks like this, but notice we have x squared minus 2x, and we have x squared minus 2ax plus a squared. So if we take a look at this and compare it with this one here, so what we have is, if we want this to be equal to x squared minus 2x, I'll move this down so it doesn't look like a division, then what we have is a equals to 1. So I'll just erase this. So what we want is, if a equals to 1, then what we end up having is, then what we have is x minus 1 squared, and then equals to here. X squared minus 2a, that's a is just 1x, is minus 2x, plus 1 squared, is just 1. So what we have is this part here, x squared minus 2x is this, so we can just move this onto the left side. So what we get is finally x squared minus 2x equals 2x minus a squared minus 1. So I'll move it there, just put it on the right side. So what we have is this equation. So we've just completed the square, and we've had a square there. So now we can throw that inside here, like that. So if we throw that inside, what we end up having is here. So thus, now we have this x minus 1 squared is going to be our x squared minus 2x. X minus 1 squared minus 1, then plus y squared equals to 0, and that's here. And then we can just move this 1 on this side. So what we end up having is x minus 1 squared plus y squared equals to 1. And this is just an equation of a circle. And then you could even go this further and write this as 1 squared, just for completeness sake. It's the same thing. If this was 4, you could write this as 2 squared, so the radius is going to be the value inside of the square. So what we have is, well, radius 1. So radius is 1 there equals 1, and this is just equation of a circle. So recall, this is a circle. Circle with radius 1. Yeah, it was radius 1. And it's also at the center. And the center of the circle is, it's going to be, well, y, there's nothing inside there, that's 0. And then here, because we have a negative 1, we put a 1 there. And you can learn more about the circles in my earlier videos, check that out. So x is 1 and y is 0. So this was negative 2, you would put it at 2. So in other words, x needs to be, to make this all 0, you need to put in x is equal to 1, so that this vanishes. Likewise here, you just put y is equal to 0, and that vanishes like that. So that is what we end up having. I'll put a exclamation mark. And yeah, I'll put the link to my video on circles in the video link below, so check that out if you want to learn more. So now if we were to graph this, what we end up having is, it's going to be a radius 1. So it's going to, let's draw this something like this, and this is y, this is x. So I'll draw this further down. So let's say 1 is here, and then the height is going to be, let's say, the same 1, and here is going to be negative 1. So it's 0, so 1, 0, this is at the center right here, and the radius is 1, so at this point it's going to touch here, and it's going to go all the way to 2 right here. So then we can just make a circle around there, and this is the top, this is the bottom. Let's draw a circle, see if I can draw a neat one. Actually, this isn't neat. This touches this, and then it goes around like that. So yeah, just fix that up. It's somewhat of a circle. It's not too accurate, but yeah, you get the idea. So it's a circle with radius 1, but also note what we can do. Yeah, what we could do is, if we had a point here, so then this point is, let's say we call that P, so that's a point P, and I'm going to draw a line across there, and then if we draw a line across this where this is theta, and then draw this across here, draw a line like this, this is in fact perpendicular, and I'll prove that in a later video. So then the hypotenuse here is going to be 2 from here to here, and then let's say this is the distance r. So what this means is, yeah, if this distance is r and polar coordinates here, we could just use the equation or the trigonometric function here, the cosine of this, which is, that's adjacent, this is a hypotenuse. So what we end up having is is r, actually no, better than that, cosine theta, if we take the trig identity. And I'll prove this, that it's actual right angle, in a later video, so stay tuned. So this is going to be adjacent over hypotenuse. It's 2 because its number radius is 1, so add it up, 1, 1. So 1, 1, that's just 2. So then what we have here is, if we write this down, move the 2 across, we get, put a better arrow. So we get r equals to 2 cosine theta, like that, and that is our polar equation. Right here, r equals 2 cosine theta. So yeah, that is pretty fascinating. And this right here, yeah, so I'll put a note, so this right here, I will solve this or prove this. I'll put a note right here, note, I will prove that it's actually a right angle so that we could use these ratios. I'll prove this in a later video. This, put a better this in my, actually in my next video, so stay tuned for that, my next video. So stay tuned. Yeah, so I'll prove that in my next video or later video, whichever comes first. So stay tuned for that. I'll prove that it's actually a right angle when you draw a line from here to here and then all the way to the other side of the circle. And also for completeness, the equation of this circle is black. The red is for polar coordinates, and then in Cartesian we have, well, x minus 1 squared plus y squared equals to 1, like that. So that's what we have in polar. This is Cartesian to polar, polar Cartesian, and there's a neat triangle that I can visually see the difference, which is quite amazing. Anyways, that's all for today. Hopefully you learned from this pretty interesting example video on converting a circle to Cartesian from polar equations. Anyways, thanks for watching. Like always, you can download these exact notes in the link below. Thanks for watching, and stay tuned for another Math Easy solution.